This is where I live. A few years ago I moved from the big city to a small village in North Holland. Here the view is unobstructed. That's why I started to notice the by-effects of aviation. On settled days the weather forecast talks of high clouds. But these clouds are often the condensation trails of jet planes. On some days the only clouds in the sky are contrails. That's why I decided to find out more about them. Are they just a visual annoyance, or are there other, more serious consequences? In 2010, European airspace was closed due to an ash cloud. The media reported the skies were exceptionally clear and blue. When the air traffic started again, blue turned back to stripes of white. With the outbreak of COVID-19, air traffic again was drastically reduced, and the Netherlands recorded the sunniest spring since record began. I decided to make an estimation of the light loss from this aviation smog. I viewed photos on the NASA website. I counted the days with visible stripes over the past 4 years. And what turned out? On average there were 168 days with stripes. 33 days a year there were very many stripes. I estimated that these stripes caused about 1% loss of light. But I was wrong. It was far more. The Meteorological Institute reported 2.5% more light during the lockdown. In other words, this pollution blocks 2.5% of the sunlight. That loss is comparable with 9 days of total darkness a year. Visitors from places like South America are surprised by the contrails they see in our skies. Trails which we seem not to notice, even though the beauty of our skies has been famous. I looked for painters who included stripes in their landscapes. In the Netherlands I only found one, Karel Stein.
Ik heb nagedacht over waarom anderen geen strepen schilderen en ik weet niet exact het antwoord, maar ik vermoed dat sommige mensen het weglaten omdat dat mooier is voor het schilderij. En ik kan me ook voorstellen dat er mensen zijn die daar helemaal geen aandacht aan besteden, als zijnde iets wat er geen rol speelt. Hier zie je een schilderij van Gerrit Adriaanszoon Berkheide, genaamd De Gouden Bocht. En die ben ik nu aan het aanpassen aan de huidige tijd. Wat ik hier geschilderd heb heeft als naam Hollandse luchten. Waarmee ik wil aangeven dat onze Hollandse luchten er tegenwoordig zo uitzien. Vroeger waren dat prachtige wolkenpartijen en nu ervaar je heel vaak dat er strepen in de lucht getrokken worden die uitwaaieren tot sluierbewolking.
The Dutch landscape gives unobstructed views. In open country, in clear weather, you'll always be able to spot airplanes in the sky. Here, nearly 2,000 airplanes fly over daily. Some make very clear trails. But is this a contrail or just a natural cloud? And is this normal cirrus or man-made cirrus? Flights between Britain and Amsterdam are high enough while over the North Sea to cause vapor trails. When a west wind blows, these trails blow over the Netherlands. This becomes obvious using time-lapse footage, and with the change in contrast, they are even easier to spot. and on some days there is no blue sky left. When looking at the time-lapse, we see these trails moving. And because many new ones are forming, it is like a conveyor belt for contrails. Above the normal clouds, you can see contrails and the remains of contrails. This means that on cloudy days, the contrails are still blocking some light. During World War II, these trails were a symbol for the battle in the skies. This is remembered on these stamps and on this painting.
And this is the new battlefront, the air front, from which we seek out the enemy. Higher and higher, climbing to reach your best operational altitude, 25,000 feet, 5 miles straight up. So high you can't be seen from the ground with the naked eye, until the exhaust of the engines mixing with the cold thin air condenses and streams the heavens with vapor trails. To the men in the ships, they're far from beautiful, for they point like beckoning fingers to the formation, signposts in the sky for the enemy to spot us. You can watch, but you can't go down to help. You keep your formation.
Ja, het is interessant natuurlijk dat men in een oorlog, in de Tweede Wereldoorlog, er al achter kwam dat vliegtuigen op grote hoogte van die sporen achterlieten. De officiële term is dan condensatiesporen of contrails. Maar ja, in de oorlogshandelingen is het niet handig als je zichtbaar bent vanaf de grond door zo'n lang spoor erachter. Dus men heeft sindsdien is men er al bezig mee geweest of je kon voorspellen onder welke omstandigheden. Dus soms heb je omstandigheden die met vochtigheid en temperatuur te maken hebben, waarbij je helemaal geen vliegtuigsporen ziet, terwijl er wel van alles vliegt. Op andere dagen vliegt er precies evenveel en dan wordt de lucht helemaal dicht getimmerd met vliegtuigsporen. Simpelweg omdat er dan hele andere omstandigheden zijn, zodat die sporen lang kunnen blijven hangen. En ja, en het interessante is natuurlijk van, hebben die vliegtuigsporen dan een bepaald effect op het weer, of liever gezegd op de temperatuur? Ja, want ja, ik ben zelf best wel een zonliefhebber. En als ik in de zon zit met mijn ogen dicht, dan voel ik met mijn ogen dicht of er een vliegtuigspoor voor de zon komt. Nou, schattingen geven aan dat dat kan oplopen tot wel 10% minder zonlicht op de grond op dagen met veel vliegtuigsporen. Denk aan bijvoorbeeld de hele nieuwe energie van zonnepanelen. Als je 10% minder opbrengst hebt op een dag met veel vliegtuigsporen, en dan is dat toch wel significant.
Eurocontrol in Maastricht makes sure the airspace above Europe is safe. They supported many research projects on air traffic and on contrails.
My name is Irene Koster. I'm an air traffic controller here at Maastricht UAC. Our airspace can be very busy because we are a little bit of a crossroad between the 4 main airports. You have Amsterdam, London, Paris, Frankfurt, and that all crosses over this part of Europe, and that's why sometimes this area looks very, very busy.
We are en route on the German Autobahn to the German Center for Air and Space Travel. Even underway, I can't help noticing the number of contrails we see over Germany.
My name is Bernd Kercher. I'm a cloud researcher here at the Institute of Atmospheric Physics at DLR in beautiful Oberpfaffenhofen. Come in, I'll show you more. Contrails are line-shaped ice clouds that form at the levels where the aircraft are cruising, typically at 8 to 13 kilometers. Now the engines of airplanes, emitting water vapor and soot particles. These are tiny solid particles. And as the exhaust emissions cool in the atmosphere and dilute, the soot particles attach water vapor in the form of a liquid layer and form liquid droplets. And because it's so cold outside at these altitudes, these tiny droplets immediately freeze and form a layer of thin ice cloud. And because the aircraft is moving so fast, this layer has a linear shape initially, and that's what we call a contrail. So depending on the temperature and humidity conditions in the air surrounding the contrails can be short-lived or long-lived. Short-lived contrails very often immediately disappear a few kilometers behind the aircraft. Long-lived contrails will stay in the atmosphere for hours, depending on the ambient meteorological conditions, and they are called persistent contrails when they live longer than 10 minutes, when they hang around longer in the atmosphere than 10 minutes. Because of their prevalence, at least in areas where a lot of air traffic is happening, they have been recognized by the World Meteorological Organization as a man-made type of clouds. They call cirrus homogenitus in their Latin parlance of classifying cloud types. There is increasing public awareness about contrails and their appearance in the atmosphere, and as they are clouds, they do exert an effect on the atmosphere and they have a climate impact. When persistent contrails evolve in the atmosphere, they tend to merge and overlap and spread out, becoming thinner and covering greater areas and forming layers of thin ice clouds, which we call contrail cirrus. And they might coexist and even form within natural cirrus clouds, which also are prevalent at these altitudes, 8 to 13 kilometers. And at times, these layers of contrails you can identify in satellite imagery very easily. They can cover areas of tens of thousands of kilometers in specific regions on the Earth, mainly Central Europe, the southeast of America and other areas. But we believe on average, if you sum up over all contrails, at all ages and over a year, they lead to a warming of the atmosphere at flight altitudes.
Both normal cirrus clouds and aeroplane cirrus retain more heat radiation than other clouds, so the temperature rises as well. Pilots have a nice view on stripes. Sometimes they fly through the stripes of their colleagues.
Even if you cannot see contrails visually anymore from the ground because they spread out and become too thin, still remnants of ice crystals, of old contrail ice crystals lingering in the atmosphere as long as the atmosphere is supporting them, producing an invisible, subvisible haze of ice crystals due to aviation emissions to old contrails. The soot emissions that make contrails can also interact with natural cloudiness when no contrails are involved in the first place.
In recent years it has become sunnier in the Netherlands. The air has become cleaner since the introduction of diesel particulate filters and catalytic converters. But the enormous growth of aviation put an end to that.
My name is Luca Bugliaro and I work here at the Institute of Atmospheric Physics. I'm an expert in satellite remote sensing. So usually when you look at the sky you can see something like this, where you can see different contrails and also contrails that are spreading into larger clouds. With satellite you can observe a much larger area and also keep track of different contrails at different times. This one is a picture taken from the Meteosat second generation satellite. So at the first sight you cannot see any contrails, but if you look in more detail you have here another perspective at the same picture from this satellite. You can see that all these lines that are plotted here in red are contrails. The area covered by these contrails is really is really large. So it goes here over France, over entire France to Germany, and then also towards Great Britain, and you have really a lot of contrails. But this shows you that these contrails first can live for many hours, and also they are built over and over again. Of course, you can also gather different observations and try to make a sort of climatology. Again, here you see Europe, so it's France and Germany, the Netherlands and Great Britain. The more red you see, the more contrails have been found using our satellite algorithm. It shows that there is a high contrail coverage over Europe because there is also a very high air traffic.
It is Sunday. It is 2 in the morning. There is a late holiday flight from Cyprus to Manchester. A Gulfstream jet crosses the channel from England. We see a plane flying from Addis Ababa to Dublin. And we see a plane from Tokyo, destination Paris. The daily invasion starts over the Atlantic Ocean. There are planes from New York, Chicago, Miami and other American airports. If we accelerate the images, we see that the air traffic above the North Sea and Europe is also starting. A few hours later, the first planes depart from Europe for America. It was clear last night, but now the sky is filled with high clouds. Weather people do their work using computer models. One of the models predicted sunny weather in the Netherlands and in France. The satellite photos show the Netherlands not sunny but covered in cirrus and contrails. In Paris the weather should also have been sunny. Despite supercomputers, satellites, weather balloons and millions of measurements, the model is unable to distinguish aircraft cirrus from natural cirrus.
Well, it's like this, that a numerical weather prediction model, which is used for making a weather forecast, does really not consider air traffic, and it also doesn't consider contrails. Yeah. But this is also a very difficult topic for us. We are studying this as well. So this transition from the linear contrail into the contrail cirrus, as soon as you lose this linear shape, it is very difficult to say this cloud or this haze cloud, this cirrus cloud, originates from a linear contrail.
There is a clear match between where people fly most and the number of contrails. Most flights happen in America, Europe and East Asia. These are the places where you can see most contrails. In our town is a man who has been writing about solar energy and solar panels for a long time.
What struck me that on some sunny days the yield was very much lower than you would expect, up to 25% less. And when I looked at satellite images and I looked at the sky myself and I saw contrails, I started to understand that these contrails make a big difference. See the 14th of February that we have a lot of sun with every now and then some minor clouds or so, and at the end of the day it drops down dramatically, so here it was very, very cloudy. Here you see the revenues of February 15th this year, which was 6.78 kilowatt hours. It was a very beautiful day. Here is the next day, February 16th. There was a day with a lot of contrails and you see 5.12 kilowatt hours. So there's a difference between those 2 days simply caused by contrails of, well, I think probably 20-25%. This is the weather for today, the weather forecast, and it will be sunny today with veil clouds. Well, we by now know that those veil clouds are not just regular veil clouds, but are contrail clouds, and I would say just call them contrail clouds because that's what they are.
Wageningen University and Research is a leader in research into plants and plant growth.
So for plants we often consider the 1% rule. 1% rule means 1% more light that you get 1% more growth of plants. It also means the opposite. If 1% less light would mean 1% less yield. So if the yield would be 1% less, that would mean many kilograms of fruits and vegetables. It would be less grass for the animals. It would be less potatoes, so less food, but also less ornamental plants. For a grower, 1% yield production can be a lot of money.
In Europe, solar panel owners and farmers lose billions of euros. Less light also means that nature converts less CO2 into oxygen. The economical damage and the damage on the environment is unacceptable. What I find even worse is recognition. The Netherlands has strict rules in the field of environment. And yet we accept that our air is regularly filled with stripes and aircraft cirrus. We either don't see it or don't want to see it. Maybe we will see something being done about it. Maybe following generations will see old films and pictures of skies filled with contrails and wonder, how could they let this happen?